sample problem 5B on page 173, and we're starting off with just the simple equation for kinetic energy, which of course you have on your note card by now, and that you've actually been familiar with since freshman or sophomore year, since physical science. What we're asked is, we have a 7-kilogram bowling ball, and we've got a velocity for it, 3 meters per second. How much kinetic energy does it have? That couldn't be a whole lot easier. So, we have our mass of our ball, we have the velocity of our ball, we want to know Ke of the ball. Mass is given as 7.00 kilograms, velocity is 3.00 meters per second, and like I said, this is ridiculously easy. So 1/2, 3.00 meters per second times, squared, times 7.00 kilograms equals the kinetic energy of the ball. 3 squared times 0.5 times 7. So what do you get? Pardon? Here's some more because I'm hoarding them up here apparently. What do you get? Yes, the number is in the book, but who's got a number for me? 31.5 what? Okay, 31.5 joules. What's a joule? Okay, it's the unit for work, it's the unit for energy. Let's back that up. Let's do the dimensional analysis. What's a joule?
Kilogram meters squared over second squared.
Okay, because 1 joule equals 1 Newton times a meter, and 1 joule therefore equals 1 kilogram times meter over second squared times meter. So yeah. Do our dimensions check out? Meters per meter squared, second squared, kilograms, we end up in joules. So don't forget to do dimensional analysis, it's real handy. Okay, that's fantastic, but that's not all they ask us. What they then ask us is, what if we have a ping pong ball? How fast would that ping pong ball have to be traveling to have the same amount of kinetic energy as the bowling ball? So let's do this. We have mass, we'll just call it mass of ping pong ball, velocity of ping pong ball, Ke of ping pong ball. Okay, we are given a mass, 2.45 grams. What do we have to do? We have to what?
Put the mass in velocity.
Oh, okay. Well, aside from that, what do we have to do? Put in kilograms, because otherwise our dimensions won't work. So let's do a kilogram conversion.
The second part of the first question.
Yeah, this is the second part of the first question. Jeez, oh, Pisa, Moser. I'm really doing a bang-up job today. 1 kilogram is equal to 1,000 grams. 2.45 divided by 1,000. We get 2.45 times 10 to the negative third. Okay, and our kinetic energy is 31.5 joules. So, solving this for velocity, Ke equals 1/2 mass velocity squared. 2 Ke divided by mass, square root of, equals velocity. Okay. Sound of glassware. So if we take this over here where we've got a little bit of space to do this, square root of 2 times 31.5 joules divided by, we could do 0.00245 kilograms will give us our velocity. Okay. What do we get for velocity? What you got?
160.356.
Okay. Yeah, 160.356.7451. What are our units? Meters per second. And does that check out? So we divided out the kilograms, and we took the square root of meters squared over seconds squared. So yeah, this would be in meters per second is our velocity. Is that a reasonable velocity for a ping pong ball? Probably not if you're just batting it back across the table at somebody. However, if you launched it out of some sort of air-powered pneumatic ping pong ball rifle, sure, I'm sure you could accelerate a ping pong ball to that kind of velocity. And it would hurt like the dickens when it whacked you. So don't do that. Okay, with sig figs, we can have what, 3? So 1 point. So velocity of the ping pong ball would have to be 1.60 times 10 to the second meters per second. Gives us 3 sig figs. Okay, fairly easy, right? The kinetic energy ones are relatively straightforward. I will assign all of the 5B problems, 1 through 5. And let's do 5C. We'll stop the video.